Hello everyone. Here in this video, we are going to solve the heat flow equation using Crank-Nicholson method. Here the problem given is u of x is equal to 16 u of t. So the given equation is u of x is equal to 16 u of t. Let this be 1. And the range of x is between 0 to 1. So here we have the range from 0 to 1, x have range from 0 to 1. And the intervals are taken like h is equal to 1 by 4. We know the intervals in x axis is h and it is given as 1 by 4. So here the x value have value 0.25. Here 0.5, here 0.75 and 1. Next is t limits. The range of t is not given, but it is given like t should be greater than 0. And also it is mentioned that compute u for one step in t direction. So it is enough to find t for only one step. So what we are going to do is we are going to take k as 1. So in this direction we are going to take here we are going to take k value as 1. So we are going to find the value of u for one step of t. So when we compare this equation, that is our given equation with the heat flow equation, we get the value of a as a is equal to 16. We know that x is equal to IH and t is equal to JK, where I is equal to 1, 2, 3, 4 and j is equal to 1. So here the points become u of 0, 0, this is u of 1, 0, this is u of 2, 0, this is u of 3, 0, this is u of 4, 0. Here this is u of 0, 1, u of 1, 1, u of 2, 1, u of 3, 1, u of 4, 1. Like we did in the earlier, that is the Schmidt recurrence relation, we are going to find the values of these mesh points using the initial and boundary conditions. Here the initial value is given as u of x, 0 is equal to 0. U of x, 0 is equal to 0. That is, for any value of x, u will be equal to 0. At t is equal to 0, u will be equal to 0. So we have all these values. So this is the initial value. Next comes the boundary value. Next is u of 0, t is equal to 0. For any value of t at x is equal to 0, u will be equal to 0. That is, this point will be equal to 0. Next is u of 1, t is equal to 100t. So for x is equal to 1 and for any value of t, u will be equal to 100t. So this term is equal to 100. So now we have the initial and boundary values. So we want to find the values of these three meshes. Let us take this to be equal to u1, this to be equal to u2 and this to be equal to u3. Okay. Now we are going to use the Crank-Nicholson formula and we are going to solve this equation. The Crank-Nicholson formula is lambda u of I plus 1, j plus 1 minus 2 lambda plus 2 u of I comma j plus 1 plus lambda u of I minus 1 comma j plus 1 is equal to minus lambda u of I plus 1 comma j plus 2 lambda minus 2 u of I comma j minus lambda u of I minus 1 comma j. So, this is the formula, Crank-Nicholson formula. Let us take this to be equation 2. Here we want to find the value of lambda. Lambda is equal to k by h square a. We have taken k to be equal to 1 and h is given and it is equal to 1 by 4, and from this equation we get a as 16. So, substituting this we get 1 by 4 square into 16 equal to 1. So, lambda value is equal to 1. Now, we are going to substitute this value here in the second equation. We get lambda u of I plus 1 comma j plus, in the place of lambda we are going to substitute the value. So, we get u of I plus 1 comma j plus 1 minus 2 plus 2 u of I comma j plus 1 plus u of I minus 1 comma j plus 1 equal to minus u of I plus 1 comma j plus 2 minus 2 u of I comma j minus u of I minus 1 comma j. So, this term gets cancelled. So, we get u of I plus 1 comma j plus 1 minus 4 u of I comma j plus 1 plus u of I minus 1 comma j plus 1 is equal to minus u of I plus 1 comma j minus u of I minus 1 comma j. Now, rearranging this equation we get u of I comma j plus 1 is equal to 1 by 4 into u of I plus 1 comma j plus 1 plus u of I minus 1 comma j plus 1 plus u of I plus 1 comma j plus u of I minus 1 comma j. So, this is equation number 3. So, using this equation we are going to find the mesh points u of 1, u2, u3. We are going to find out these values. So, using this equation we are going to find the values of u1, u2, u3. First we are going to find out u1. u1 is nothing but u of 1 comma 1. For that we need to take I should be equal to 1 and j is equal to 0. So, u of 1 comma 1 is equal to 1 by 4. U of we have taken I is equal to 1. So, u of 2 comma 1 plus u of 1 minus 1 is 0, 0 comma 1 plus u of 1 plus 1 is 2, 2 comma 0 plus u of 0 comma 0. U of 2 comma 1 is u2. So, we need to find that u2. Then u of 0 comma 1 is given, that is u of 0 comma 1 is 0. U of 2 comma 0 is also 0. U of 0 comma 0 is also 0. So, we have u1 is equal to 1 by 4 u2. This is equation number 4. Now, we are going to find out the second point u2. For that, u of 2 comma, which is u of 2 comma 1, for that we take I equal to 2 and j equal to 0. So, 1 by 4 u of 3 comma 1 plus u of 1 comma 1 plus u of 3 comma 0 plus u of 1 comma 0. So, 1 by 4 u of 3 comma 1 is u3, u of 1 comma 1 is u1 and u of 3 comma 0 is 0, u of 1 comma 0 is also 0. So, u2 is equal to 1 by 4 u3 plus u1. This is equation number 5. Next is we are going to find out u3. u3 is equal to u of 3 comma 1. For that we take I equal to 3 and j equal to 0. u of 3 comma 1 equal to 1 by 4, u of 4 comma 1 plus u of 2 comma 1 plus u of 4 comma 0 plus u of 2 comma 0. So, u of 4 comma 1 is 100, u of 2 comma 1 is u2 and u of 4 comma 0 is 0, u of 2 comma 0 is also 0. So, we get u3 equal to 1 by 4 100 plus u2. This is equation number 6. Now we are going to substitute the fourth and sixth equation in fifth equation, and we are going to solve and find out the values of u1, u2 and u3. So, substituting fourth and sixth in equation 5, we get u2 equal to 1 by 4, 1 by 4 into 100 plus u2 plus 1 by 4 u2, which is equal to 1 by 4 25 plus 1 by 4 u2 plus 1 by 4 u2, which is 25 plus u2 by, so because this is 2 u2 by 4, so we get u2 by 2. So, rearranging, we get, we can write it as 25 by 4 plus u2 by 8, and rearranging we get u2 minus u2 by 8 is equal to 25 by 4. So, from that we are going to take u2 outside, 1 minus 1 by 8 equal to 25 by 4. So, this is 8 minus 1 So, we get 50 by 7, u2 value as 50 by 7. Now, substituting this value here for u1, so this is 7, then for u2 we substitute the value 50 by 7. So, we get u1 value, this is the u1 value. The same way we can find out the value of u3. So, the value of u3 is 26.7857. Here the value of u1 is, solving we get the answer like u1 is 1.7857, and in such a way we can find the value of u1, u2 and u3. So, this is how we can solve the heat flow equation using Crank-Nicholson method. Thank you.